Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a critique of NASA's 10 rules for software development, a set of guidelines designed for the high-stakes world of spacecraft programming. It's a fascinating discussion.
I'm eager to hear this. These rules are famously strict. What's the main point of this critique?
The critique argues that while these rules are excellent for embedded systems in space exploration, where safety is paramount, they're overly restrictive and even detrimental for other software development contexts, like compiler development or general application software. The author, you see, believes that blindly applying these rules without considering the specific context can lead to less maintainable, less readable, and even less reliable code.
Interesting. So it's not a blanket rejection of the rules, but a contextual challenge?
Exactly. The author highlights the trade-off between rigorous control and practical development. For example, the rule against dynamic memory allocation is great for embedded systems with fixed memory, but it can stifle flexibility and efficiency in other applications. Think about the implications for large-scale applications.
Right. And what about the limitations on control flow? The ban on go-to, recursion, and even exception handling seems extreme.
Precisely. The author points out that while eliminating these constructs guarantees termination, it can lead to convoluted code that's harder to understand and maintain. The example of nested loops with an astronomically large upper bound illustrates this perfectly, theoretically bounded, but practically infinite. It's a compelling argument.
I see. But isn't the goal of NASA's rules to minimize the risk of catastrophic failure? Isn't that worth the trade-off?
That's a crucial point. The author acknowledges the importance of safety in mission-critical systems. However, the critique suggests that the rules, while effective in their intended context, are not universally applicable. The author even suggests that a better approach might be to use a language like SPRK-ADA, which is designed for verification, rather than imposing such strict limitations on C.
That's a good point. What about the rule limiting function length? 60 lines of code per function seems restrictive.
Yes. The author argues that the focus should be on code readability and comprehension, not arbitrary line limits. The critique suggests that a well-structured function, even if longer than 60 lines, can be easier to understand than a series of shorter, fragmented functions. It's about the logical structure, not the line count.
I get it. And the restrictions on pointers and function pointers? Those seem particularly limiting in modern programming.
Absolutely. The author argues that these restrictions hinder the use of abstract data types and object-oriented programming techniques, both crucial for managing complexity in larger projects. The example of simulating function pointers through enums is a clear illustration of how these restrictions can lead to less elegant and more error-prone code. It's a powerful argument against the blanket application of these rules.
So the overall message is that context matters. These rules, while valuable in high-risk environments, aren't a one-size-fits-all solution.
Exactly. The critique advocates for critical thinking and adapting best practices to the specific needs of the project. It's a call for a more nuanced approach to software development, one that values both safety and practicality. It's a really thought-provoking analysis.
It certainly is. Thanks for breaking it down for us.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time. Goodbye.
Bye-bye.